In this video, I'm going to show you some unusual polar graphs when the equation is in this form, r equals a sine theta plus b, or r equals a cosine theta plus b. You might remember from a past video that r equals like 2 sine theta. If there is no b, I'll just say plus 0. So when there is no b, or let me call it 4 sine theta plus b, that had 0, 0 as a point, and had 94 as a point. And it ends up becoming a circle. So I guess the first case is so in the equation r equals a sine theta plus b. If b equals 0, it's going to be a circle. And it's going to be a circle whose center is on the theta equals 90 line. But when there's a plus b, it actually gets kind of complicated. So I'm going to take you through that. So again, our first example. And here I have. This is kind of the example that we just did. I want to show you a side-by-side comparison of the x, y graph. This is an idea for creating graphs. We haven't done this before. Here's the x, y graph. Y equals 2 sine x plus 0. Well, that's a sine curve that looks like this. Now here's r equals 2 sine theta. And the way this works is every point on the left, like this is the point 0, 0, that corresponds to the point 0, 0 degrees on this. And this point over here, which is 90, 1, that corresponds to the point, 90, 2. That corresponds to the point 2, 90, because this is xy, but this is r theta, like that. And if we were to make a table of values, the xy table would have x as the independent variable. But when we do the r theta, it's the theta that's the independent variable. So it's kind of confusing, like these numbers seem to be backwards. And then, when I get back here to 180, 0, that corresponds to this point again. In fact, I'm going to make this point blue, this point red, and this one green, but that ends up here again. So just with those 2 points, it doesn't seem like a lot of information. I'm going to throw in another point here. I'll make it yellow. That's like 45, like square root of 2. That would be like over here. And kind of out of colors, but I'll go like that. That's like 135, also somewhere around the square root of 2. So if you look at these pieces, I'm going to make this red from here to here. That corresponds to that piece. And from here I'll make this whole piece yellow. That corresponds to that. And this part I'll make blue. That corresponds to this. And this part I'll make gray. So actually halfway through it actually creates the circle. But what happens if I keep on going? Well, this point here is 270, negative 2. And 270, negative 2 is actually still up here. So what happens is I'm going to kind of make this red again. That actually corresponds to this same piece, just like that piece is. Sorry. This red, let me just go halfway. And then from here to here is actually overlapping with this yellow piece. And from here to here is overlapping with this blue piece. And from here to here is overlapping. So it actually makes 2 circles, although you wouldn't know by looking at it here. It looks like a circle. But it's actually 2 circles, which is a little bit confusing. But this is the graph. Now what happens if b is not 0? Like y equals 2 sine x plus 3. Well, that graph is moved up by 3. So like the center point here is at 3 instead of 0. I'll make 4 different colors here. Now let's see how this translates onto the polar graph. Well, this initial point is no longer 0, 0, but it is 0, 3, which over here corresponds to the point 3, 0, which is over here. So that's not the center anymore. This blue point up here is 90, 5, and if I plot 95, it's going to be like up here, and I'll make this arc corresponds to that arc. Now this green point over here is at 180, 3, which is like that. Sorry, I should have made that blue. Okay. So just compare what's going on. This is kind of going to the right, and this is like spiraling around. Now what happens here, this green point? Well, it's got to go from 183 down to 270, 1. Now 271 on this one is really 1, 270. It's over there. So what happens is that we don't actually end up with a circle anymore. We end up with kind of a distorted thing. This is at 3 and this is at 1, so it kind of has to get whoops. Something like that happens. Move this a little. And over here, something like that happens. So it kind of looks like, it looks almost like an ellipse, but it's actually not an ellipse. And when we graph it on a graphing calculator, we find that over here there's like a little, almost like an indentation occurs. But that's the basic idea. It's not a circle anymore, I guess, is the main thing that I'm trying to get at here. This shape is called a cardioid because it kind of resembles an upside down. Sorry, this one's not called a cardioid. It's actually called a Limacon. I don't know exactly how you pronounce it, but it's got French accent over there. Okay, we'll look at some more examples. In this case, it's y equals 2 sine x plus 2. So we have a and b are equal to each other. Oh, in this last one, b was greater than a, so we get a picture like that. Before we had b equals 0. This is when where b and a are equal to each other. And if I'll go ahead and do the red, blue, green, yellow. So those points correspond to 2, 0, 490, 270, 0, and 360, 2. A point that I left out is this one over here, which is real important. That is 180, 2, somewhere over there. Now here's a red arc. See how it goes from 2 this arc corresponds to this arc. It's kind of like this isn't a straight line, but even if it was a straight line, this would be a spiral. So this is kind of like a spiraling thing. And this is also kind of like a spiral, but it's spiraling sort of inward. This gray one, see how the x, the y values are all positive? So this is kind of like it's sort of spiraling inward, because the r value is getting smaller and smaller, and then this green part is going to spiral outward. And that one is called a cardioid because it looks like an upside down heart. Now the next example is y equals 2 sine x plus 1. So here's the one where b is less than a. We already saw b equals 0, so that's an example of b is less than a. But here's b is less than a, but greater than 0. And this is the most confusing one. I'll start with this point, which is 0, 1. I'll go to this point here, which is 93. This arc here is kind of like that. It's kind of like a spiral, an arc of like a spiral. This point here is real important. That's 180, 181. So, and I'm going to actually make this blue arc. But here's where something interesting happens that didn't happen before. We've never had this before. There is a Y-intercept right here. That's important. Yes, I know this point's important also. Why don't I make that yellow? That's 270 comma negative 1. Well, 270 negative 1 is over here somewhere. But to really get a feel for what happened, because it's really hard to connect these dots. Again, at the end, I'm back to 361, which is here again. But these 4 dots are not so useful in making the picture, because that yellow dot's kind of in the middle of nowhere. So I'm going to see this gray dot there? That's an important one. That one is, this is 180, this is 270. That one is at 135, comma 0. And 135, comma 0 is right on the pole. So I have a green arc from here to here. That's going to look like that. Back to the center. So sort of like the cardioid. But here's where something important happens. This gray piece from here to here, that's negative. It's like 136 degrees, 137 degrees, things like that. So, sorry, I shouldn't be saying 137. 220. This is at 225, comma 0. So when I get between 225 and 270, I'm actually pointing in this direction, but I'm going backwards. So that's why it goes like that. And that is kind of hard. This gray thing became that. And same thing kind of happens from here to that spot. That's black, and it ends up with this loop here. Because when I'm at this is 270, the yellow is 270, comma negative 1. So when I go to 271, comma negative 1, I end up over here, right in this spot. And finally, I'll get back to I'm out of colors, so I'll just reuse red from here to here. Well, that's okay. That's just like that. So we end up with what's called a limacon with an inner loop. And that is a little bit confusing. But what we've seen here is limacon with inner loop. That's where b is less than a. This happens because it goes below the x-axis. The inner loop happens. This one, we don't go below the x-axis. We hit it. That's where we get this pointy part for the cardioid. That's where a and b are equal. In this one, b is bigger than a. It never crosses the axis here, so we end up with something that's more circular, and this one was actually it was 2 circles. It hit below the axis, but because of the symmetry, it was below. This is almost actually like a limacon with an inner loop, but the inner loop is the same size as the outer loop. One thing I want to mention before ending this video is this can also be done with cosine curves. And the same sorts of things happen. Why don't I do this one as a... I'll do this one. So for a cosine curve, this first point is at 0, 4, which is actually over here. And this point in the middle is at 92, which is like over here. And this point over here is at 270, which is on the pole. And this point here, sorry, this is 180, which is still on the pole. This is 272, which is over here somewhere. And then back to the first point. This arc, you see how it's getting lower? So that corresponds to like almost like a spiraling inward. And this part is also getting closer to 0, so it spirals like that. And here, it kind of spirals outward. And from here to here, it spirals outward. So we end up with a cardioid again. But in this case, it's sort of it's rotated 90 degrees, and that's going to happen for all of these curves. If we change cosine to sine, we'll see that it's no longer symmetrical about the sort of y-axis, but it's symmetrical about the x-axis. We'll learn about symmetry in another video. Might as well just do the other two here. So in this one, this was the limacon that did not have the inner loop. We have this thing going on. Kind of goes like that. So it ends up being a rotated version of that one, and so here's a cosine one where b is less than a. Again, these are all in the form a cosine or a sine theta plus b. Now, when b is less than a, the curve goes on the rectangle, goes below the x-axis. That's going to cause a inner loop in the polar picture. So let's take a look. Here is 0. That's 0, 3. So I'm going to graph 3, 0 somewhere over here. And this point here is 92. Which is something like that. And this point here is, well, let me start with this one. This point down here is 180, comma, -1, which is actually over here. So it gets, and why don't I just get two more points here. This point over here is 270, 270, comma 2, which is over here, and the last point is back to here. So those 4 points are not like so useful, and if I throw in this green point, which is let's see, it's between 90 and 180, so it's 135, comma 0, but it's over here right in the center, and this point over here is 225. Well, it's also right there in the, maybe I should make this different. I should make maybe that gray and that red. I like that better. That's also in the middle. So it's really not looking so good. We got these sort of weird 1, 2, 3, 4, 5, 6 points, 2 on top of each other. But if I now look at it one piece at a time, this arc here turns into that. And this blue arc, you see how it goes down to the zeros. Doesn't even matter if we know what the actual x-coordinate is. The main thing is it goes to 0. It becomes an x-intercept. X-intercepts turn into the pole there. And this is the most important one, this green piece. Because it's negative, the angle is bigger than 135, but because it's negative, we end up with this sort of backwards thing. That's basically, I'm pointing in this direction, but I'm going backwards. I get to this yellow point here. Now from here to here, now I'm past 180, so I'm pointing in this direction, but I'm walking backwards because these are negative, and that's why I'm getting that to happen. And then I've got this gray thing spiraling out, and this one. So we end up with a limit zone with an inner loop. Well, those are the curves. It is pretty confusing, but I hope by going through these different examples, it's making some sense, some more sense to you.